Hi there, and welcome to this ECG webinar. We are going to be sharing about SIP integration capabilities. Our title is Call Me Maybe, Guide to SIP Integration in the Cloud Era. My name is Mark Lindsay, and I'm here with my colleague, Matt Keithley, who I'll ask to introduce himself in just a moment. We've both been with ECG for a number of years, worked with a lot of different clients on doing SIP integration, both from the voice service provider side and the application developer side. So a little bit about ECG. We do voice network engineering. We work with service providers and enterprises to build robust voice networks, primarily for those connecting to the telephone network, so that numbers can be dialed, so that emergency calls can be placed, things like that. We also work with internet service providers. A lot of our clients are both internet service providers and voice providers. We have a mixture of public sector and service provider customers, and we do training and operations. What we're doing today is a bit of training where we're educating you, the app developer or the voice service provider, on kind of the issues of SIP integration for app developers as you're bringing vertical market or other specialized AI-based applications, for example, to interconnect with voice service providers. Like I said, my name is Mark Lindsay. I'm here with Matt Keithley. Matt, can you introduce yourself?
Yeah. Hi, I'm Matt Keithley. I've been with ECG for many years now. My actual title is Special Projects Developer, but I'm mainly just a software developer. I do software architecting, specifically designing large applications in the integration with SIP products and anything that we're like seeing on the cutting edge that we're working on. So yeah.
Welcome. Yeah, thanks, Matt, for joining. So I am one of our voice network engineers, working with helping service providers build and expand their services and their functionalities. Let me tell you a story. Suppose you're an app developer and you are building apps for your clients. Maybe they work in the insurance industry or the dental or medical industry, and you're good at this. You're normal for you for interacting with external services is to use protocols like REST over HTTPS. For authentication, you're accustomed to using firewall ACLs where IP addresses are listed, and then also TLS certificates are probably pretty common for you to use as a way of authentication, at least on server side authentication, maybe client side authentication as well, to check to be sure your client is authorized to talk to the particular server. Use domain names to route traffic. That's pretty normal for you. You're building your app to connect between different um, application delivery controllers, ADCs, load balancers, maybe across multiple clouds. But you're using domain names to like decide where that traffic's going to go. You use availability zones instead of data centers. You don't really think in terms of data centers anymore. Availability zones, in Amazon US East 1 or US West 2, you use these different availability zones to determine where your functions are. You don't really care about exactly which data center it's in. In fact, that might even change. Your software updates are automatic, so you're regularly pushing out new software updates, and you have the ability to do rollbacks instantly on your production software. So you're doing that on a regular basis. And you really rely on software modules from, let's just say, 57 different sources. So if you look at your bill of materials for your software package, all your open source credits, it's a pretty long list for obvious reasons. You're pulling in lots of different components, and you're using a lot of different APIs to get things done. So if you've got a web application, it's talking to a dozen different servers to load up your web application on the screen. So that would be kind of your normal world. Your primarily way. The thing I want to emphasize here is you're primarily working with REST APIs to get these things done. Now contrast that with the typical voice service provider, and your work is providing voice service to companies and consumers. You use SIP over UDP. That's your standard application protocol. So that's a common way that you would deliver phone calls. You do authentication, but you do it with SIP because SIP has a built-in authentication mechanism, and with firewall ACLs, that would be common. So you would have designated IP addresses that are allowed to send that SIP, and that's what makes your authentication work. Use domain names, but they're mostly as names and occasionally to route traffic a little bit. So, for example, if you do some integration with Microsoft Teams, that you have to use domain names to get traffic to them, to the Teams phone system or to Operator Connect, things like that. but you've carefully designed your data centers to minimize latency. So you're really specific about things. You're not just interested in the zone or region of the country, but specifically the data center. You don't do software updates that frequently because there's just the number of things that have to be touched and checked manually in order to do a software update. So you do them, quarterly is a good goal. Every year you have of several software updates, and you probably for any given call you probably have four major vendors that are involved. The software vendors that are involved, and maybe the VoIP endpoint or the software that's running on the customer side, the session border controller, the call controller, the application server that's routing that call, the PSTN gateway that you're sending it to a service provider. You really don't have that many different active providers. So if you needed to get everybody together to troubleshoot a problem, it's really it's a half a dozen different organizations maybe. For app developers, SIP is actually a pretty difficult protocol to use. So that's the distinction that we see if we think about the background of that app developer against the background of a voice service provider. A lot of SIP folks who've interacted with SIP early on, they will struggle some as they get started. So there's some quotes from developer forums. SIP is dead. Long live WebRTC. It's one thing that's said. HTTP has its problems, but implementing it is a cakewalk compared to things like SIP and all the RFCs. And somebody else said, I wouldn't call SIP exactly simple or an easy protocol to follow and implement. What we're seeing there is that SIP works the way it comes in a inheritance from other voice protocols where you send messages to establish the beginning of the call. And really it comes out of a heritage of the 1980s and 1990s of protocols that were used for remote procedure calls and for other kind of client server applications and peer-to-peer applications. It's not built under kind of the newer model, the REST model that came about in the early 2000s, really. So that's why the title of our presentation today is Call Me Maybe. And sometimes it's hard to just get a single phone call to go through. An app developer, if they can't integrate their application with the voice service provider via SIP, then they can't use the phone network, or at least they can't use that one. And there are sometimes you really need to use a specific voice provider, or you need to integrate with a SIP gateway. I'll talk about that in a moment. So our general topic here is, what do the app developers need to know about SIP? What do the voice service providers need to know about app developers in order to be able to work together to maximize the integration of SIP for SIP trunking or SIP devices with what app developers need to do, the vertical market applications? Because vertical market applications are a lot of where we see applications and communication going. So if you're, for example, an insurance agency, then you have very specific needs for the compliance obligations that you have as an insurance company. While there are companies that are built for providing software to insurance agencies, and they know about those compliance needs. And so going to one of those and getting your voice services might be a logical option. You want to be able to get your vertical application for your regulated industry from somebody who knows about that. Well, if you have to go buy phone service from somebody that's separate, then you have to do a lot of that tying together yourself, or else they have to do it for you. And so the trend in vertical applications is that, especially for regulated industries or industries with complex customer communication requirements, that the vertical market app developer is really playing a really big role in the telecommunications. SIP integration is really key. So I got some examples here of the some of the different vertical and horizontal applications that are integrated with SIP. Just these are basically, it's the majority of horizontal voice AI agents that are integrated with SIP. One of the key ones I want to mention, ECG supports SIP, of course, in our AI voice intelligence applications and services. Most AI voice agents support SIP integration. So for example, OpenAI has a SIP integration for their voice agent. VoiceFlow is another one. Lindy is another big player. There's a lot of these out there. We looked at them, and there's about 60% of the AI voice agents that actually have SIP support today, where that AI agent can talk over SIP either to a service provider or to a enterprise PBX. Many vertical market apps are also adding SIP support. So just a few examples: Housecall Pro. They provide home services. So if you're a contracting company or a builder, you might use Housecall Pro as part of managing that. Well, they have a SIP integration so that they can connect to your voice service provider or your PBX. AMS Plus is an example of one of those vertical market applications for insurance agencies. Call Review in the automobile dealer space They provide a SIP integration. Of course, you've got companies like ADP. There are others in all of these categories that actually also support SIP as well. These are just a handful that I wanted to highlight. And so you might ask, well, why would they use SIP instead of something like WebRTC or other APIs? And let's talk about that. It's a great question. It's very legitimate that you're gonna have times when these are the right option to use. So WebRTC provides you an option when you're providing a phone application where you might want to connect the video or the audio and or both, and you want to set up a video call. So if you're trying to make a calling application so that, for example, the worker in the field can able to take a call through the system, through the app, and be able to talk to the customer without having to manually dial a number on their personal cell phone, then WebRTC can be the right option for building that because it's really customized. It's intended to build dialer or phone applications, end user phone applications. Whereas if you have a dialer application or if you have a voice agent and you need to connect to the network, then WebRTC is really not your answer. WebRTC is about connecting to a client presentation, a end user presentation of the phone call. CPaaS vendors, so calling platform as a service vendors such as Twilio and Bandwidth and Cinch, just to pick a few of the really big ones, they provide APIs that can be used that can be simpler than using SIP. But these only give you access to those service providers. This is a part of their secret sauce. They want to be able to provide you the ability to make and receive calls in a convenient to program way using that one provider. So, for example, if you're happy with what Twilio is giving to you, you can use SIP with Twilio, but you can also use the REST API. Same thing with Bandwidth and Cinch. And in fact, I was speaking with a CEO of one company in our space just this week who was saying the nice thing about these APIs is that they can't be copyrighted. That's been shown in at least US law. And so other companies can actually provide the same API as another company for competitive advantage. So you could build your application potentially against one of these providers and then potentially move it over to a competitor and not have to rewrite it. You'd be using two different companies. And so that can be a really great option to have a really simple way to start and manage calls for these particular providers. But that still doesn't solve the whole problem. You're going to run into cases where you need to do an integration with a particular provider. So let's say, for example, you're working for one of these public sector organizations. They have contracts with a provider. Let's just pick Verizon, just to pick one. Well, those contracts are with Verizon. The calls will be going in and out through Verizon because of the existing contract. If you want to sell your vertical application into that, let's say it's a state contract with Verizon and they have a state owned hospital that's part of their university system, then those phone calls are going to have to go through Verizon. Well, if Verizon doesn't provide you the API integration that you want, then you've got one option left, which is SIP. You could say the same thing true of a number of different service providers around the world, where if you want to sell your service to one of their customers, you probably are going to need to be able to integrate over SIP with that particular service provider. So that starts to show kind of where you can use the API, the REST API sometimes, and sometimes you got to use the SIP interface. Another example of where this is important is when you need to connect not to the service provider, but to the enterprise PBX. Let's take a company like Bank of America or another company like UPS. Global multinational companies. You might want to do business with one of these global multinational companies, and they run a large internal complex of PBXs internally. If you want to be able to get traffic in and out of their network, you're not going to send it directly to a Twilio or directly to a Lumen or an Orange or a Telstra. You're going to need to send it to their PBX. That's how you're going to integrate with it if you want to be able to offer it. Well, those PBXs don't provide the same CPaaS APIs that you're going to be able to get from Twilio. They provide a SIP interface. You're going to be able to do SIP trunking to that. And so that's another case where you're going to need SIP support to be able to provide your application to those large multinational enterprises. You could say the same thing about integrating with Microsoft Teams. Yeah, you can build an app that runs in a window inside Microsoft Teams, but if you're actually going to send traffic in and out of their network, then you're going to be using their SIP gateway to do a lot of that stuff. Even though obviously Microsoft has a lot of internal APIs, those are not calling APIs that are accessible to app developers as of today. And then a last example, in addition to talking about service provider integration, talking about enterprise PBXs, the last example is endpoints. There are applications where you need your application. There's a situation where you need your application to talk to an actual SIP standard endpoint. So for example, if you're in the restaurant space, there's a lot of applications where communication inside restaurants happens over phones. It's not because they want to call Chef John, they want to call the person working at that particular station, and the front desk, or a particular location in the kitchen, or a particular part of the kitchen. Well, they don't need an individual, so calling to an individual like in a Microsoft Teams type of environment isn't the right situation there. They need to call a location. And so for that location, they're going to need the device, and the standard devices speak SIP. So if you're calling any of these applications where you need a location to be called, you could think of also of emergency phone situations. You could think of first responder type situations where your job is to call a desk or a location, a building, or need to call from a building. Then those applications need to be able to use SIP phones. So for those kinds of situations, you're going to need to have SIP integration, not for SIP trunking necessarily, but for SIP endpoint integration, where you're working with SIP, but you're working with it from an endpoint perspective. So you might have a SIP phone in the dentist office, and the SIP phone is there for purposes of making emergency calls or for calling back to a particular examining room, regardless of who happens to be in that room at the time. Well, that's going to be a SIP phone that you're going to be integrating with. And so even if you're happy with a provider through another interface for other purposes, having that SIP phone integration can be really useful. And that's what we see, for example, with some of the dental practice software. They have other integrations for the PSTN side of the connection, but they have standard SIP phone integrations for communicating with the phones inside the business that are meant for the front desk or for the other operational parts of the business. So SIP actually provides a really universally useful integration point. So it may be something, even if you've got a Twilio integration today, you might look at adding a SIP integration as your customers demand it down the road. And that's why we're looking at helping you to support SIP in your network. But there are a lot of things. I'm going to introduce a lot of the things that potentially you're going to need to be aware of as an app developer, to just know that this is something that you need to have on your radar to be able to build your SIP application to work with a SIP provider. These are the kinds of things that come up. And if you're a voice provider, these are the kinds of things that your app developer friends that you're trying to support and bring on your network, they may not know how to do right out of the box, or their expectations are going to be different maybe than yours are. So I want to bring these both to light because they're things that you may not have already thought of. So first, let's talk here. We're just going to go over a few of these in detail. I'm just going to introduce them now. First, SIP transport. So we said that, the guy working in the voice service provider, he's most comfortable with SIP over UDP, unencrypted. That would be common. But there's a lot of other options. So SIP over TCP is a really common option. And these days, even though SIP over TCP is kind of gradually crept up, SIP over TLS has become much more common. So SIP over TLS gives you encryption of that SIP signaling. And this is broadly the recommended way to implement a new SIP application today, is it over SIP over TLS. Implementing something with SIP over UDP can be really useful. It gives you backwards compatibility, but it's not really considered the state of the art for traffic across the public internet or for any kind of networks where you're going to have any scrutiny on the security. So if anybody's going to be looking at the security of your application, whether it's for SOC 2 compliance or for HIPAA or GDPR, or for any kind of government security compliance, any kind of regulated financial industry type of compliance infrastructures, then you're going to be thinking about SIP over TLS. SIP stack options. So there really aren't that many options you've got for the software that you're going to be putting into place to actually place and receive calls. You might look out there and you find some open source options that you want to start with. You might go to some vendors, but there really are very few legit options that you're going to be able to use as an app developer. And then also from the perspective of a service provider, you're probably going to be working with a relatively small number of SIP stacks. Contrast that with the service provider software, where you might have application servers and call processing software from Cisco, 2 different versions from Cisco, multiple versions from Ribbon, versions from Alianza, Metaswitch, versions from NetSapiens, Crescendo, versions from Porta-1, FreeSwitch, 2600 Hertz. You're going to potentially have a lot of options there. You could add in Oracle, you could add in Telco Bridges. They're going to have a lot of SIP stack options that you're going to be potentially talking to. The number that's available for new app developers today is pretty short. Another one here we will drill into a little bit is packet capture. So normally service providers set up their networks to be able to do packet capture for troubleshooting pretty efficiently. Another one here is TLS certificates and certificate authorities. So we're probably accustomed as app developers to integrations with a standard set of certificate authorities, whereas in the voice world, the number of certificate authorities that are kind of automatically trusted by default by SIP endpoints or by SIP session border controllers, it's going to be pretty short, and you're going to have to manage the certificate authorities in a direct way. You're going to have to say, hey, I'm using the thought certificate, this signing certificate, this particular one, and manage the chain of certificates to make that work. You're not going to get kind of an automatic free list the way we do typically in an API environment, or like the CA browser forum certificate list. The HTTP post mindset is something that's a big difference. Whereas with SIP, we send a message and then we expect it to be processed and get a response code. With HTTPS, the HTTP and post in particular, the way that we go about making requests and waiting on responses is substantially different. The timeouts, the structure of kind of how do we get a follow up on this information, it's different because it's built under a strict client server model, not a peer to peer model the way you had with SIP. Another one that's different is domain names. We will spend some time on that in a few minutes, but the way the domain names are used, and DNS in particular, but domain names in general, and how they appear in SIP headers, it's a lot different than what you'd have in HTTP or similar applications. Now, a few of these options, I've already mentioned TLS a couple of times. In addition to TLS, the audio in voice is encrypted with a separate protocol, SRTP, which uses symmetric encryption. And the actual way that we negotiate that encryption, that SRTP cryptography negotiation, and then the available encryption formats is vary. So the encryption means, mechanisms, protocols, those actually vary somewhat. And getting some agreement in what's possible for your key negotiation and the key length, that's going to be some variation and that you'll have to be aware of. For a lot of voice providers, they're not really aware of working with us once they do their TLS and SRTP integration. The phones are pre-configured to actually use a particular form of encryption. Whereas if you're a new app developer, you're going to have a lot of options available to you. Telephone number formatting is another one. Figuring out how to know a phone number is valid or what format phone numbers are to be provided in is a challenge often for app developers. And then contact and via headers. It's kind of related to our domain names here, but indicating how responses and future requests as part of this call are going to process. That's just a lot different from the way you would do an HTTP application with posts and endpoint URIs. So these are some of the major things. These are really the major things that we see a lot that really show up in application development. We'd welcome your questions or comments on these. We're just going to drill down into a few of them. We're going to talk about domain names, telephone number formatting, and packet capture for troubleshooting, and we'll spend a few minutes on each of those. I'm going to ask Matt to jump in and begin our explanation here about these issues.
Sure. Let me open this up. Does this look good?
Great.
All right, so we're going to start with telephone number formatting. Now, this is not an insurmountable problem, but it is something that will hang people up. The key struggle here is the actual format of the numbers. Developers are familiar with how they personally dial phones, but those are rarely just right for SIP trunking providers. We rarely dial in E164 format. We definitely never add a plus. There are some software libraries that will attempt to standardize numbers, but they all fail. This is like if you were adding a library that helps you, has maybe a telephone number class inside of it, and it's going to store your numbers. You'll be surprised how often those do not work due to a number of factors that we'll go through. Many service providers limit the telephone numbers that can be used as the calling party number, the from, when making calls. And call screening is important for call authentication. So just some formats that we're going to talk about. E164 format with deleting plus. You see there on the invite here, we have the +1 229 316 0013. We see it in the from and the to there. And we've got the national format, which is just the 10-digit format without deleting +1. These are just some examples. It doesn't need to be, it can also just be extensions, which can be varying lengths. You can see dialing with just 7 digits. And asking yourself how many digits does there have to be in a phone number starts being complicated. The SIP address of record format that it expects the endpoint to just figure out what it means because it doesn't clarify that the digits represent a telephone number. So in this case, this looks like a telephone number, but it's not necessarily a telephone number. This actually could just be a URI or a record for the user. The historical format for calling international numbers from the US, which is a 011 instead of the +1. This also occurs. All of those you need to be aware of when you're actually going to be formatting or validating numbers, especially. Validation is one of the ones that comes up to most to me, which is when I'm designing an application and I'm going to be making sure that my numbers actually are the way they're expected. You have to be very liberal in the way that you actually do that validation. One of the best things to do there is to check actually who you're integrating with and what they expect. So if they expect E164, that's what you should be anticipating that your numbers that are being sent out are going to be in. And you need to actually check this and validate it. E164 is the most common and the most uniform format that you can use. But that leaves out a lot of things that are used, like short codes, extensions, many other things, 911, like that. So you have to be aware of that and be willing to actually look into that. Domain names are another that fall into a similar category. This is where domain names behave one way for app developers typically, and that's different than the way that we see SIP providers use them. So developers use domain names for internet domains, not shockingly, but domains are used in a lot of different ways in SIP, and knowing which one can be tricky. So some voice providers try to live in a domain name free world where they just use IP addresses, but app developers almost never operate like this. A lot of times in SIP, you're going to be using specific IP addresses in a way that we just never use when we're developing endpoints. You don't expect to actually send directly to IP addresses, but you will do that when you're using SIP frequently. The domain name for a SIP server location. So a domain name like vwave.net can be used to actually find the right IP address of a destination server, but it's not just DNS A records like with most applications. It uses DNS SRV and NAPTR as explained in RFC 3263. For SIP traffic going from the voice provider towards a cloud hosted app, using the right domain name in the right way requires a mindset shift from the ordinary web API development. We'll show some examples of what we mean by that. So suppose an app developer sends this invite to a VoIP carrier SBC. You'll see that the invite is in E164 number at voipcode.com, and that's the telephone number. You see that same domain name is used in the invite from and to, but in the contact header, we see an EC2 address that would be from an AWS EC2 instance that's dynamically generated. And then the via header then again uses the IP address. And you might look at this and say, okay, well, this makes sense, but it would not work. In this case, I mentioned this already, but the VoIPco is the domain name of the SIP service provider and for the SIP header purposes, the internal IP address of the Kubernetes pod where the container is running, and then the domain name for the reserved IP address for the domain name of the specific server that sent the call. So this is a common gotcha. And app developers need to know that how the contact and via headers work for routing subsequent requests. This is something that you do need to be aware of. That is a common pitfall when routing SIP requests compared to routing your typical HTTP request. None of those are the domain name used to actually route the SIP message across the internet, which is the outbound proxy. So in this example, we have the actual routing domain name that's used that's provided by the provider isn't actually voipco.com, it's voipco.net, and it actually has a subdomain on it. It's the SIP trunk app123. So we're actually going to be using that to do the actual routing of the outer packet that contains this SIP message. And then it can even be more complex because on the way back, as yet another domain name is used to send the call from the VoIP service provider to the app. So the domain name used to send it back is at sip.appdeveloper.net. I think next we're going to look at packet capture for troubleshooting. I'm going to stop sharing here.
Thanks, Matt, for that. Yeah, so packet capture is one of the standard capabilities that a lot of voice service providers are going to assume that they have available, whereas app developers don't always have this available to them. So packet capture means, of course, that you can get a copy of the SIP and RTP packets, maybe even the TCP and TLS negotiation packets. You can get those from um, the network at different points in the network. So if I'm a voice service provider and you're an app developer, I might ask you to provide me a packet capture. Show me what the TLS connection looks like whenever I send that first TCP send packet, and then we go into we do send and then send ACK and then ACK, and then so we've got a TCP connection, and then we start to do TLS negotiation, and we want to negotiate that because we're troubleshooting a TLS certificate negotiation problem, or maybe we're troubleshooting a key length problem, crypto algorithm, or signing a hash algorithm. So we're trying to troubleshoot that. We need to see the TLS traffic. Well, app developers don't always have that level of visibility. They're running in an environment where the first packet that comes into them has already been through a NAT device, or it's that connection is actually going to a separate load balancer platform, and they're not even managing. They're not writing the software that receives that. So a lot of applications or components of applications are functionally serverless, where you can consume a service from a load balancer server or some other kind of server, but you're not actually running software as the app developer. You're not running software that really has any access to the raw copy of the packets. For voice service providers, this is just crazy talk. Like you can't run a network that way. Whereas the app developers say, well, I've built an app this way and I've made this application work with other providers. And so this ability to get packet captures when you need it is really essential. And it's something that's often missing, especially with apps that are developed in cloud environments. But you could also think of this if you're running an app that's running and you're providing it to end users, and they're trying to run the app on one of these, then how are you going to get a packet capture of the traffic coming in from maybe the cellular network before it gets to the application here? You, as an app developer, may just not have the tools to do it. And so the voice service providers have to understand that. One of the other things, as noted on the slide here, is that voice service providers will often want to see the SIP, but the traffic is actually encrypted. And in a lot of regulated environments or high security environments, you can't really get a copy of unencrypted traffic. As the app developer, you can process it and you can emit log messages about it, but you're not really supposed to be able to decrypt it. And if you do decrypt it, then there's specific controls to ensure that that's not used for nefarious purposes. That we know who has a copy of that. If we're decrypting it and we're having to use a key log to be able to decrypt TLS traffic with PFS, for example, then we're going to know that that's running. We're going to have alerts that we're currently running in a vulnerable format. And so there's going to be a lot of infrastructure and support to ensure the bad guys are not using our troubleshooting against us. Well, voice service providers have generally not had to operate like that. They've been able to assume that traffic was either unencrypted, or if it's encrypted, then it's quickly decrypted before it gets into the interesting part of the network. And so modern application developer really does not lend itself to packet capture. This is one of the key difficulties. Traffic can be routed to a compute instance through several layers of application firewalls and load balancers, so that the app developer really literally may have no access to that packet. And as I mentioned, security first prohibitions may strictly prohibit decrypting or logging the data that could have sensitive information. So for example, under HIPAA, or if you're using the NIST 800-53 guidelines, then you're going to land at a place where you really don't want to be decrypting production traffic. App developers simply may never be able to provide the packet captures of SIP and RTP traffic. So sometimes you're going to be troubleshooting based on logs. You're going to be troubleshooting based on some sort of emitted decode of the SIP that's after it's potentially been through a few phases. And so as an app developer, you're going to want to provide the best troubleshooting capabilities that are available to you to be able to see inside the SIP messaging, to see what you can about the TLS. So for example, you may not manage the TLS connection itself, but if you have access to debug the TLS session to see how it's being negotiated, what crypto algorithm or signing or hash algorithm is being used, what key links are being used. If you can see things about the certificates and the certificate validation process, then that may suffice to solve the problem. But from the VoIP service provider's perspective, that may put you on the side where, well, you're not able to get the same packet capture that you're accustomed to getting from your VoIP customers, but you're going to need to be able to read through logs and troubleshoot that way. So really, developers and VoIP providers need to be able to work together on all of these particular challenges. And these are, this honeycomb really shows all of them that we see come up with any kind of regularity for VoIP providers. So thanks for coming. We appreciate you joining us today. We would love to chat with you some more. There's a written version of this full report covering kind of all of the elements of that honeycomb that's coming out that you'll get a copy of for attending this webinar. And we'd love to help you integrate your SIP applications. So thanks for coming. Matt, any final words?
I don't think so. Thanks for having me.
Great. Looks like we do have one question that came in we can cover. A TLS operates at layer 4 while SIP is an application layer protocol. While regarding SIP headers like contact and via, how strictly must their IP addresses match the transport layer addressing, given that the TLS certificate is validated at that layer? If the certificate is tied to the IP address shown in the contact, is the certificate tied to the IP shown in the contact? In practice, when should we use FQDNs rather than raw IP addresses? So several things, great questions here from Jeff. So what he's saying is basically this TLS validation is happening at one layer, whereas a lot of the application, so in the application layer, basically the SIP messaging is happening kind of above that. Where I've seen challenges is that the certificate validation happens largely when the app developers want it to happen, but the most common case is when a client is connecting to a server. And so, for example, if the server, a session border controller, identifies itself as spc.voipco.net, then and the client is connecting to it as IP address 4.5.6.7, then the client may be looking to validate that either a common name or an alternative subject alternative name is something like 4.5.6.7. So it's not going to be looking for spc.voipco.net. So if you've configured that, that's the outbound proxy case that we were talking about. And I can actually go back and show that slide. 1 second, I'll switch back. From the domain name section. So here we've got the app developer, the voice service provider, the first device there, the session border controller may recognize it as a voipco.net as the domain name, and it may be providing a certificate for voipco.net. The app developer in the example I gave verbally is like they've just hard coded in an IP address, 4.5.6.7. Well, you're going to have probably an HTTPS validation problem if you're doing normal TLS validation in that particular case. So that's on this outbound proxy side. And Jeff asked us about kind of 3 different versions of that. So that in that one case, it probably really does matter that you do use the proper domain name for, let's say, your outbound proxy setting that you would that's expected by the other side. And we see it in the other side here, sip.appdeveloper.net, the voice service provider. As their most common, like Matt called them, living in a domain name free world is often the attempt. You might see a voice service provider who did a DNS lookup and then they hard coded in the IP address of whatever they found for sip.appdeveloper.net into their session border controller, and then they put it in there and it worked at first, at least for DNS lookup. Well, if it's gonna do TLS validation, then the client in this case, which is the SBC initiating this connection, is going to need to do validation against the name that it's expecting it to have. And then the server, in this case, the app developer, is going to need to provide a certificate for matching whatever that client name was. So the perfect model here would be for all parties to agree to use the domain name. As Matt pointed out, that's one of the areas where app developers and voice providers will sometimes butt heads a little bit. One thing that's helping us on this particular issue move in the right direction is that Microsoft is really strong on using domain names. Like from the beginning, they've been using domain names for all of the Microsoft Teams SIP integration products. So a lot of voice providers, at least for part of their network, they've actually gotten to be pretty competent about dealing with DNS, doing the DNS lookups, being able to do TLS certificate validation for those connections. So that's one piece of it out of the four, or two pieces of it out of the four, that I think is relevant. So basically, what I see is that they're pretty strict. And Matt, I'll give you a moment here to add in as well on the contact header and via header. So here's an example of contact and via. In this particular case, we're using SIP. It doesn't show it as encrypted. It seems to be UDP port 5060, as it says there. So we're not doing any encryption on this particular case. So there wouldn't be, in this particular case, even if it's TLS connection here, we're actually asking for the replies to come back as unencrypted SIP. That might be a problem. So in an app trying to troubleshoot this problem, that looks like that could go wrong, because the app may be expecting to send back the follow-up SIP messages through the TLS connection that's already negotiated. That'd be a totally normal thing to do. Or potentially initiate a new TLS connection if it's an application that requires TLS to be in place. In those particular cases, it's going to have a little problem here because it's trying to connect to this server and it doesn't look like the server supports it. But let's go to this example here, because this is one where we've got some potential for TLS. We've at least got a domain name here. Jeff asked, basically, is the certificate tied to the IP address shown in the contact? In this case, we've got a domain name or a via header. You would want to be sure that the certificate provided did match the names that are given here, so that as this voice service provider, let's say they're going to send a follow-up bye message to close out that call, to end the dialogue, then what you're going to expect with the contact header is they're actually going to use the contact header, and that, yeah, they would connect back and actually check the client, in this case, the voice service provider sending the bye message, is going to check the TLS certificate of the server to see if it matches what it's expecting. So it would expect to get a server certificate for this domain name, EC2-44-226, etc. It's going to try to get a domain name for that, which means that you're probably going to need to manage what goes in that contact header to match the domain names that you can actually speak for and gets TLS certificates for. In the via header, this indicates where replies should be sent back to. And so the via header, if the reply routes back across the same connection, you may have more flexibility, and that's really commonly the case. But if it has to initiate a new TLS connection to connect back, and that sometimes happens, you'll have a client that connects from port 49152, and it's initiated a connection, but the via header actually says, well, no, you need to connect back to port 5060 or port 5061. Then the other side, in this case, the UAS, the user agent server side, might need to initiate a new connection. And when it does that initiation, it's going to do client certificate, it's going to do server certificate validation and confirm that the certificate matches what it was expecting. So I think that all that to say, yes, the certificates are going to be checked in general on standard equipment. So I'm thinking of standard software, for example, the Oracle Session Border Controller or the Broadworks application server, just to pick two examples. They're going to do the type of TLS server validation that you would expect from any client. Even something as simple as curl is gonna normally check the certificates, and so you're going to get that. So in practice, when should we use FQDNs rather than raw IP addresses? My preference is to use FQDNs whenever you can, but whenever you can is going to be determined by the integration capabilities of the device you're talking to. So if you're talking to a voice service provider and they've got the ability to just turn it on and use it, and maybe they've done some custom integration, SIP integrations before, then they're going to be in good shape about doing DNS lookups. In other cases, you're going to be talking to somebody and they're going to say, well, I can take two IP addresses. Tell me what two IP addresses they connect to. I can't actually do, I can do TLS, but I can't do domain name lookups. Well, in that case, you may need to add support for being able to accept those connections and then provide back a certificate that's appropriate to allow that validation. Or you tell the service provider, well, I'm providing certificates, but you're going to have to turn off certificate validation for this connection because my certificates are based on my domain names. What I've seen some service providers who, if they tried a little bit, they could start to use FQDNs if they wanted to. One of my clients was in that particular role where they could turn on FQDNs if they gave it some effort. It just was not something that they had a lot of maturity about doing. So whenever you can use FQDNs, it would be my general goal. Matt, I'd be interested if you had any thoughts on or reflections on these issues of certificate matching and TLS applications with SIP.
Yeah, most of what you said was what I was going to say. That um, with it, the practice part is I always try to use FQDNs first. It's just it frequently you'll find out that, especially the way SIP stacks just work out of the box, they're frequently going to send back IPs, and that's just how they're going to work. And so you're going to have to actually make effort to allow them to use FQDNs, even make modifications sometimes. It depends on which side of this equation you're on. But it's frequently more difficult than you expect. And so it's just something you have to be aware of, that it's going to be a sticky point. Um, just keep that in mind as you go into this. Was there anything else to that question? Or did you answer all of them? Let me
I
see.
think we covered it at least in part. Jeff, great question. Thanks for adding that.
Yeah.
Well, we don't have any other questions. So if you do have one, you're welcome to share, add a question in here. We do thank you guys for attending.
Yep.
And we'll see you on a future webinar. Thanks very much.
Thank you.